Hey, what's going on, guys? Let's look at this problem right here. Here we have W1 and W2 are given. Both of them are complex number. One of them, this W1 is in rectangular form and this W2 is in polar form. The first question is asking express W1 plus W2 in standard rectangular form. Now let's see how to do this. First, W1 is already in the standard rectangular form. W1 is equal to 3 plus J4. But we have to convert W2 into rectangular form. This is in polar form. W2 is equal to 2 e power j 5 over 4. So whenever we have an exponential complex number, we can convert this one into polar form using Euler's identity. Euler's identity says that whenever we have something like this one can be expressed as 2 times cos the angle, that is 5 over 4, plus j times sine 5 over 4. And we know that 5 over 4 is equal to 1 over root 2. So we have to put 2 times 1 over root 2 plus j times 1 over root 2. And if we multiply, that's going to give us 2 over root 2 plus j 2 over root 2. So this is our standard rectangular form for W2. But we want to find what is W1 plus W2 is. Let's go ahead and add them together. W1 plus W2. The real part of the W1 is 3. And real part of the W2 is 2 over root 2, so we can add them together. 3 plus 2 over root 2 plus the imaginary part of the W1. Let's take the j common first, and the imaginary part of the W1 is equal to 4, and the imaginary part of the W2 is equal to 2 over root 2. So this is going to be 4 plus 2 over root 2, and this is going to be our final answer. Okay, now we have done the first part. Now let's go ahead and do the second part. Let's get rid of this one. The second part is asking, the B part is asking, express W1 minus W2 in standard polar form. So the first thing what we can do is, since we know both of them in the rectangular form, first we can subtract this one in the rectangular form, then we can convert that one into polar form. Now let's go ahead and do that. So this is going to be what? W1 minus W2. We know that W1 is equal to 3 plus J4. And the W2 is equal to 2 over root 2 plus j root 2 over root 2. Now when we subtract, first we subtract the real part, so that's going to be 3 minus 2 over root 2, and then plus j, and then we can subtract the imaginary part, that's 4 minus 2 over root 2. Okay, so this is what we are getting when we subtract. Now let's see, and also instead of, I should have done this one before too. Like when we have 2 over root 2, we can simplify this one. Like we know that root 2 times root 2 is equal to 2, right? So if I put that one in top, one of the root 2 in the denominator cancel, so finally we can express this one as 3 minus root 2. And we can do the same thing for this one. This is going to be j 4 minus root 2. Okay, so in that way it looks similar. I should have done the same thing before too. So in that way we can get a simpler expression. So W1 minus W2 is available right now. Now when we have the rectangular form, what we do is, to find the polar form, first we find the angle. First we find the distance. So if I put it in the graph, the real part is going to be this one, this 3 minus root 2. And the imaginary part is going to be in the y-axis, that's going to be 4 minus root 2. So if I draw this is going to be the location of the complex number, and this is what we are interested in finding, r. Because if we want to express this one into polar form, we have to know what is this r is, and also we have to find out what is this angle is. Okay. Now to find the r, we can use the Pythagorean theorem. Pythagorean theorem says what r is equal to square root of 3 minus 2 square root of root 2 square plus 4 minus square root of 2 square. And if you calculate this one, you are going to get 3.033. So this is our r distance. Now we have to find out what is this angle is. If I use tan theta is equal to what? Opposite over adjacent. Opposite is 4 minus root 2. 4 minus root 2 divided by adjacent 3 minus root 2. Therefore theta is going to be tan inverse 4 minus root 2 divided by 3 minus root 2, and that's going to be equivalent to 0.3255. so this is going to be the angle. Now we have the angle and the r value, so finally we can express our answer in polar form. So the polar form answer is going to be 3.033 e power j 0.3255, and that's going to be our final answer. So this is going to be the part B. Now let's go ahead and do the part C. Part C says express W1 W2 in standard rectangular form. Okay, so we have to multiply. Let's get rid of this B part because we need rectangular. A part we needed because we have the rectangular part. So let's get rid of B part and simplify. Okay, let's get rid of this whole thing. Okay, so here we are going to do this C part. Now before I do that, I better simplify this one first. So this one can be written as root 2 plus j root 2, because we know that 2 can be written as root 2 times root 2. So one of the root 2 in the denominator cancels, so we can get root 2 plus j root 2. Okay, now let's go ahead and do the C part. C part is asking express W1 W2 in standard rectangular form. W1 is what? Okay, we are going to find W1 times W2. W1 is 3 plus j4. W2 is equal to square root of 2 plus j square root of 2. Now in order to do this one, we just have to FOIL it. 3 times root 2, 3 times j root 2, j4 root 2, j4 j square root of 2. Okay, now let's simplify this one. 3 times root 2, that's going to be 3 root 2. Then 3 times j root 2, that's going to be 3 j root 2. And then j4 times root 2, that's going to be j4 root 2, j4 root 2, and then j4 times j root 2. So here we have to be careful. J is what? Square root of negative 1. J square is going to be negative 1. So when we multiply, this is going to be j square 4 root 2. So j square is negative 1. So negative 4 root 2. So this is what we are having right now. Now when we combine the real part and the imaginary part together, 3 minus 4 root 2, that's going to be negative root 2, because 3 minus 4, negative 1, so negative root 2. 3 plus 4, you can think it like 3j root 2 plus 4j root 2, that's going to be 7j root 2, or you can say j7 root 2, right? So this is going to be the final answer for this one, W1 times W2. Now let's look at the D part. Express W1 over W2 in standard polar form. Okay, in order to do this one, what we have to do is we have to convert W1 into polar form first, then we can divide. In that way it's easy. Okay, let's get rid of this one. Okay, this one. Okay, let's look at the D part. D part W1 over W2. W1 is in the rectangular form. We have to convert this one into polar form. So let's look at the graph. W1 is going to be 3 in the real part, 4 in the imaginary part, and we have to find what is R is, and also we have to find the angle. Since this is a 3, 4, 5 triangle, this is going to be just 5. You can calculate using Pythagorean theorem. 4 square 16, 3 square 9, 16 plus 9 25, square root of 25, that's going to give us 5. Okay, and we can calculate the angle using tan theta. Tan theta is equal to opposite over hypotenuse, opposite over adjacent, 4 over 3. So theta is going to be tan inverse 4 over 3. Tan inverse 4 over 3, that's going to give us 0.2955. So this is the angle we are getting right now. Now we know the radius, that is, the distance, that is 5, and the angle is this one, so e power j 0.2955. So this is the rectangular, this is the polar form of this one, this W1. Okay, W1 is equal to this. W2 is already in the polar form, so we can just go ahead and divide these two, and see what we get. Okay, W1 divided by W2. W1 is what? W1 is equal to this one. We just figured it out. That's 5 e power j 0.2955 divided by W2 is what? W2 is already in polar form. That's 2 e power j 5 over 4. So 5 over 2, that's 2.5. And e power, when you subtract these two, you are going to get 0.0455, because when you divide the power, exponentials subtract, right? The powers will subtract when you divide, right? So finally you will end up with 0.0455, and that's going to be the final answer. And that's how we do this kind of problems. I hope this helps. Thanks for watching.